Hello, my name is Rob Reynolds. Welcome to Calculus Section 2.2. Today we're going to look more closely at the definition of limits. Previously we had looked in Section 2.1 at the approach from the left and right by using our calculators, and I just wanted to show you again if you wanted to use your table setup under second window and change your independent from auto to ask, then you can just go under your table under second graph and literally just ask what number you're looking for the approach. So if x is 2.999, then the y value is around 197.98. Now be careful, if I add one more 9, 1, 2, 3, 4 nines, it looks like it's at 198, but I would encourage you to highlight the y value to find out that it's really not. The calculator's rounding that. So read from below the 197.998 to be accurate and get correct answers on MyMathLab. So a good definition of the limits is it's about the journey, not the destination. I'm worried about the approach, not where the value of y is. So for example, looking at a graph, if I ask for the value of f at 1, I'm really looking for the y value at x equals 1. So if you let x be 1, you can see the y value is a 2. But in the second part, it's asking for the limit of the function as x approaches 1. And the limit really is the left approach and the right approach. So the left approach is approaching 2 from the left and approaching 2 from the right. So it's also a 2. So f at 2 is here. It doesn't look like it exists at f at 2, but it does. It's this point right up here. So I would say f at 2 is 5. And the limit also exists, but it's not at 5 because its approach from the left and from the right approaching 3. Even though the function doesn't exist, remember it's not about the destination, it's about the approach as it comes. So f at 3 does not exist. I have a hole there. But the approach from the left and the right is approaching 4. In other words, from the left, it looks like it's getting really, really close. You can see these points. If I let x be 2.9999, then I'm really close to 4. And if I let x be 3.0001, I'm really close to. On this next example, they're asking us to go back to our calculator and kind of look at the left approach and the right approach from our table setup. So let me show you a trick for typing in a fraction. If you hit alpha y equals and then press enter, it'll give you a fraction so that you don't have to use parentheses to type in the square root of x minus 1 divided by x minus 1. A little bit easier to type in. Then I want to evaluate this, so I'm going to go make sure under my table setup that I have it set for my independent variable to be asking. And then under second graph, I'll use a 0.99, a 0.999, 0.9999, and so on and so forth. And then from the right approach, it's 1.0001. And again, I'll highlight those y values to see the exact values. So placing these under your table setups, you can see these answers. So remember, limits are about the approach. It's not about the destination. So for example, number 3, I'm looking for the limit from the right, and then I'm going to look from the limit from the left, and then I'll look at the limit at. If the limit from the right is equal from the limit from the left, then the limit will exist. So we'll start with the right. The limit as x approaches 2 from the right. You can see I can't just do direct substitution because if I plug a 2 in for the denominator, I'll be dividing by 0. So I'm going to try to factor, which is one of the techniques that I have learned for evaluating limits. And to factor cubes, I write down the bases. You square the first, take the product, square the last. First you keep the sign, change it, last one's always plus. And now I can cancel the x minus 2's and evaluate the limit of just the factors that are left. So x squared plus 2x plus 4 divided by 4. If I plug a 2 in, I'll get 4 plus 4 plus 4 divided by 4, which is 12/4 or just 3. Then notice that if I were to change the problem from the limit as x approaches 2 from the left, nothing really changes. I'm just looking at numbers that are really close from the left side. So I still get a 3. So the limit from the left is equal from the limit to the right. And again, if we looked at this graphically, we can see the approach from the left and the approach from the right is the same. We can even look at the table setup. Here's the approach from the left of 2. Here's the approach from the right. And everything is approaching 3 from the left and the right. In this next example, we have the limit from the left approaching a y value of 4, and we have the limit from the right of 2 approaching at only a 1. So if the limit from the left does not equal the limit from the right, then we say the limit does not exist. Well, 5 is talking about not just looking at a few values. You need to look at many values to figure out the approach. Looking at this, it's kind of deceiving. It looks like it's approaching -1, but if you look at values that are even closer to 0, you can see that the function cosine of 1 over x is actually kind of oscillating between -1 and +1. So we'll say the limit does not exist. Here are some problems from your book. I hope you've downloaded the PDF file so you can work along or work ahead for some of these skills. This says evaluate the function at 2. In this case, it's 5. The limit as it approaches from the left and the right is a 3. Part C says what's the function evaluated at 4, and it does not exist. This says what's the limit as it approaches 4, and that's the approach from the left and the right. Looks like it's a 1. And the limit as x approaches 5 looks like, well, from the left and the right, it's both a 2. And you could either check answers with the back of the book or right here. If you run across a problem that you cannot evaluate the limit at 2 because it'll cause you to divide by 0 and you can't factor it, remember, one of the techniques that we have is just going back to our calculator and looking at the left approach of 2 and the right approach of 2, and then determining what the y values are approaching, and it appears that they're getting closer and closer to 0. This is a good exercise, and this is something that I think you should be able to come up with answers and practice on your own before you try MyMathLab. Go ahead and just pause the video, try to answer these, and then I'll share my thoughts of what I think the answers are. Okay, if you're ready, here we go. This says what's the function at -1? And again, it's not the open dot, it's this closed dot, so I would say 3. Part B says, what's the limit as x approaches -1 from the left? So here's -1 approaching from the left. Looks like it's a 2. Part C is -1 from the right, and it's also a 2. -1 for the g function is a 2. G at 1 is also 2. And since the limit as x approaches 1 from the left is a 4, but from the right is a 5, we would say the limit as x approaches 1 does not exist. The limit as it approaches 3 is -4. G at 5 is 5. And the limit as x approaches 5 from the left would also be 5. I don't have a limit as x approaches from the right. I just can't even see the function. So I would almost say if they were to ask for the limit as x approaches 5 of the g at x function, I would say it does not exist because I don't know what's happening. Maybe the function's up here and there's a break. I hope you found this video helpful. Good luck with your homework. Email me with your questions.